Hello everyone! In this video, you will learn how to recover data from a destroyed RAID array of RAID 0 and RAID 1 levels created using the built-in AMD Motherboard controller RAIDXpert2 Configuration Utility. We will take a detailed look at a topic that is relevant for many PC users based on AMD processors: how to access data on RAID array disks after a motherboard failure, and what measures will help minimize the risk of losing information in the future. Most AMD motherboards support two main types of RAID arrays: RAID 0, used to increase data read and write speed; RAID 1, the so-called mirror, which provides increased reliability for storing important information. In this video, I will show how to create such arrays, and most importantly, what to do if the RAID has been destroyed, the motherboard has failed, or the array was accidentally deleted or modified in the BIOS. How to create RAID using AMD RAIDXpert2 Configuration Utility. Let's start with the process of creating a RAID array using the AMD RAIDXpert2 Configuration Utility. The setup procedure for RAID 0 and RAID 1 is practically identical. The difference lies only in choosing the RAID level. As an example, I will use an ASRock motherboard. However, the general principle of actions remains the same for other AMD-based motherboards. First, you need to enter BIOS or UEFI. To do this, restart the computer and during system startup, press the Del key or the F2 key. Which exact key is used on your device is usually shown on the boot screen. After entering UEFI, go to the Advanced section and open Storage Configuration. Here, find the SATA mode parameter and change its value from AHCI to RAID. After that, save the changes and restart the computer. Next, we need to enter BIOS or UEFI again. After booting, go to the Advanced section where the RAIDXpert2 Configuration Utility item will appear. Open this utility and go to the Array Management section. To create a new RAID array, select Create Array and specify the required RAID level. RAID 0 is used to increase performance speed. However, it does not provide fault tolerance, so if one of the disks fails, data recovery will be extremely difficult. RAID 1, on the contrary, ensures reliable storage by mirroring the data to the second drive. After selecting the array level, proceed to choosing the physical disks. Specify the media type, mark the required drives, and activate them. After confirming the changes, you can, if necessary, configure the block size and caching parameters. To complete the process, click Create Array, after which the RAID array will be created. Now you can boot the computer and install the operating system. It is important to consider that if the system was previously installed in AHCI mode, after switching the controller to RAID mode, it will most likely stop booting. In that case, you will need to reinstall the operating system. After installing the OS, the system will detect the RAID array as a single logical disk ready for storing and working with data. The most common RAID array problems and how to solve them correctly. Now let's look at several typical situations that may arise during RAID array operation. The first situation, you have RAID 1 configured, the so-called mirror, and one of the disks fails. During system boot, you will see the array status critical or degraded. This means the array has entered a degraded state. However, all data is still located on the healthy disk and remains accessible. To restore the array's functionality, you need to turn off the computer and replace the failed drive with a new one. After that, enter BIOS or UEFI again and open the AMD RAIDXpert2 utility. In some cases, the new disk is not detected automatically, so it must be assigned manually. To do this, go to the Disk Management section, select the new drive, and specify Assign Global Hot Spare, meaning assign it as a global spare disk. As soon as you apply this change, the RAID controller will automatically start the rebuild process, rebuilding the array. During this procedure, the data from the healthy disk will be copied to the new drive, and after the process is completed, RAID 1 will return to normal working condition. The second situation is much more complex and dangerous in terms of data preservation. Imagine you had RAID 0 configured and a serious failure occurred. For example, the motherboard failed, after which you connected the disks to another computer, or the RAID array was accidentally deleted during BIOS configuration. With such a connection, the operating system will detect each disk as a separate drive because it will not be able to recognize that they were previously part of a RAID array. As a result, Windows will immediately prompt you to initialize or format the disks for further use. At this moment, it is extremely important not to agree to these actions. Initialization or formatting will overwrite service information and significantly reduce, in some cases completely destroy, the chances of successful data recovery. To retrieve information in such a situation, you will need specialized software capable of correctly determining the RAID array parameters, assembling it in virtual mode, and providing access to the data stored on those disks. This exact approach makes it possible to recover files even after RAID 0 destruction. Recovering data from RAID 0 using Hetman RAID Recovery. Hetman RAID Recovery is a universal solution for restoring RAID operation and data lost due to its destruction. The program supports most file systems and RAID types and will help you recover lost data. Follow the link in the video description, download and install the program. After launch, we see that the program failed to assemble the RAID array automatically, so in this case, it must be assembled manually. For this, we will need the exact RAID array parameters, based on which correct reconstruction and further data recovery will be performed. Determining RAID parameters for GUID partitions, or GPT. Modern operating systems such as Windows and Mac OS use the GUID partition table scheme, or GPT, by default. This scheme has standard signatures that make it easy to determine the beginning of partitions. On the array we are examining, an NTFS partition was created in a GUID system. In this case, a standard set of bytes is written to the disk. The beginning of a GPT partition is determined by the byte sequence 4546492050415254, which in text form is EFI part. In the previous sector, as a rule, at the end there is the byte sequence 55AA. The built-in HEX editor of the program will help us find these signatures. To do this, right-click the disk and select HEX editor. For convenience, use the search function. Click the search icon. Enter the sequence 4546492050415254. Specify that we are searching for HEX values and click Find. After finding this sequence on the disk, we determine the beginning of the GPT partition. The sector that ends with 55AA will be the offset from which the useful partition information begins. For example, if the EFI part signature is found in sector 1,069,057, then the offset for working with the partition will be 1,069,056 sectors. This signature is standard for GPT partitions and allows you to correctly determine the offset from which the array should be assembled. In the program, sectors are visually separated by a stripe, which makes it easier to navigate the disk. How to manually assemble a RAID array. Now that we know the offset of the GPT partition start, we can proceed to manually assembling the RAID array. Open the RAID constructor and select the option Create Manually. In the window that appears, specify the RAID type, in my case, RAID 0. Then set the block size by entering the parameters that were used during the initial creation of the array. For AMD motherboards, these are usually blocks of size 64 or 128 kilobytes. Next, add the disks that made up the array and specify their order. Special attention must be paid to the data offset. Select the first drive, choose Change Offset, and enter the value found earlier, 1,069,056. Change the units to sectors and confirm. For the second disk, specify the same offset and confirm as well. Here, you can also enable the Update Automatically option so that the program correctly displays the changes. If all parameters are specified correctly, in the lower part of the window we will see the result, the created RAID array and its partitions. All that remains is to click Add, after which the array will appear in the main program window and will be ready for further data recovery, scanning, and data recovery. Now that the RAID array is assembled, it can be scanned and the required information extracted. Right-click the partition and select Open. In the next window, choose the analysis type, Fast Scan or Full Analysis. During a fast scan, the program will instantly display the found files. Here, you can mark those that need to be recovered and click the Recover button. Then, specify the saving path, a disk or a folder, and click Recover again. If the required files were not found during the fast scan, you should run Full Analysis. To do this, return to the main program menu, right-click the disk, and select Analyze again. Then, choose Full Analysis and the file system. Full Analysis takes more time because a deeper search algorithm is used. After the analysis is completed, go to the folder with the found files, mark the necessary ones, and click Recover. Thus, this is a standard situation for GUID partitions. Today, GPT is the default partition scheme for new Windows and macOS systems. For MBR partitions, the situation is somewhat different, but despite that, determining the offset and assembling RAID manually is also possible. How an MBR partition begins. MBR, or Master Boot Record, is an older partition scheme. Unlike GPT, MBR partitions do not have a single fixed signature at the beginning of each partition. Instead, the first sector of each partition, called the Volume Boot Record, or VBR, contains unique bytes that depend on the file system used, for example, NTFS, FAT32, and others. Thus, in an MBR system, each partition on the disk begins not with a fixed signature, as in GPT, but with the first sector, the boot sector, or VBR. The format of this sector is determined by the specific file system and contains all the necessary data for recognizing and working with the partition. The first sector of a partition, or VBR, takes up 512 bytes and contains several important elements. At the beginning, there is a JMP instruction with a length of 3 bytes. Next, the file system name is specified, known as the OEM name, which occupies 8 bytes. After that comes the BIOS parameter block, as well as the service structures of the file system itself that are necessary for the partition to work. And at the end of this sector, there is always the standard signature 55AA or 0x55AA, which serves as a marker of VBR completion. You can also open the disk through the hex editor and search for partition signatures. For NTFS, you need to find the byte sequence EB5290 4E5446 53202020. The first 3 bytes, EB5290, are the JMP instruction, and the next bytes, 4E5446 53202020, represent the file system name NTFS. After the JMP instruction, the file system name always follows. Be sure to make sure that this sector ends with the signature 55AA. For FAT32, the first bytes of the partition look like EB5890 4D 535749 4E 34 2E31, which corresponds to the file system name MSWin4.1. For exFAT, the first bytes of the sector are EB7690 4558 4641 54202020, and the file system name is exFAT. How to recover RAID 1. In the case of RAID 1, the program also failed to determine the parameters automatically. First, you need to find the offset of the partition start. Open the disk through the HEX editor. Search for the byte sequence 4546 4920 5041 5254. Specify that we are searching for HEX values and click Find. As a result, we determine the offset, 1,069,056 sectors. Next, open the RAID constructor and set the array parameters. Choose RAID 1, add the disks, and specify the offset 1,069,056 sectors for the first disk. For the second disk, enter the same value. If we convert this offset into bytes, we get 547,356,672. Be sure to enable the Update Automatically option and click Add, after which the array appears in the main program window. Now you can scan the partition. Right-click the partition and select Open, then specify the analysis type, Fast Scan. After scanning is completed, open the disk, mark the required files, and click Recover, specifying the path where to save them. Thus, even if the RAID 1 parameters were not determined automatically, you can manually assemble the array and recover all the necessary information from it. As you can see, motherboards for AMD processors provide quite convenient tools for creating RAID arrays, but no one is protected from failures. Therefore, always remember, backing up important data is the best way to protect yourself from losing information. If the data has still been lost, Hetman RAID Recovery will help you recover files while ignoring hardware errors, whether it's a controller problem, a motherboard problem, or accidental array deletion. That's all. I hope this video helped you understand recovery from a destroyed RAID array. Don't forget to like and subscribe to our channel. Thank you all for watching. Goodbye.